afternoon. I just want to make sure that you guys see the slides. So today I'd like to present
We can see your slides, Dr. Tobias.
Right. Some of the work that we have done at ABC with regards to the determination of product and process impurities by a mass spec-based method called MRM, which stands for multiple reaction monitoring. Sometimes it's called SRM, selected reaction monitoring. And if you've worked with small molecule drugs, this is a quite established technique, particularly in the bioanalytical or PK or pharmacokinetic studies, and in the quantitation of small molecule drugs. Now, the basis for MRM is differences in mass. So essentially, the MRM I apologize, my computer just, basically the MRM determines the quantitation based in differences in mass, which I'm going to talk on the next few slides. Basically, if we know the mass, we can design a method to target specifically a product impurity, for example, a isoform or variant, or a process impurity which is in your product if you wanted to monitor it during the manufacturing process. So this is an example of a diagram of a monoclonal antibody where it shows different areas that the MRM can be used. MRM, because it is targeting a specific peptide or a specific mass, for as long as there are differences in the mass, you can design an assay for. For example, deamidation. Deamidation meaning you have a difference of 1 Dalton compared to the native, so you can design a what we call transition ion between the native and the deamidated form. Oxidation is another example, which typically happens in methionine residues in monoclonal antibodies. Typically, you have a +16, so you can design a transition pair to target the native as well as the oxidized form. And you know, a variety of things you can do, whether it's truncation or even on peptide mapping to complement the UV. You can also target specific peptides in the map of interest. Now, typically in a manufacturing setup, you would have a variety of impurities, whether it's coming from the process itself, where you have your cells. Typically, you would have host cell protein impurities or host cell nucleic acid or antibiotics. And in this particular case, we'll have an example for an impurity that we're going to determine by MRM. And detergent, for example, twin, that is typically used for to solubilize the protein. At the same time, one can also observe impurities that are product related. And these are impurities that are basically protein modification. So for example, if you have what we call a charge variance, meaning to say that it's the same mass, but there is some modification either in the N-terminus or downstream in the sequence. For as long as there's a difference in mass, you can design an MRM method to distinguish between the native and the variants. And again, as I mentioned earlier, you can also determine if there are deamidation, because there's a difference of mass there, as well as methionine oxidation. Now, in this talk, I'll be talking about 2 case studies, mainly for product impurity, and then Dr. Anders will come in the middle of the talk, and he will talk about the an impurity based on the process. So case 1. Case 1 is a recombinant protein, which is basically a fusion protein. And what was observed was, and again, the scheme down here shows just a typical purification process where you would have your culture and then harvest, and you do your extraction, precipitation, and then your first column, UFDF, where you buffer exchange, dilute, and you do your polishing step, and so on.